Hello and welcome to today's webcast, Navigating the Amazon Web Services Platform. My name is Evelyn Hayes and I'm a Business Intelligence and Analytics Consultant at Farragut, based in our London office. Today I will be joined by my colleague Scott Stieritz, who will be presenting from our Philadelphia office. You can also feel free to get in touch with us via our contact details on the screen, and we'll share those details again at the end of the presentation. So let's have a look at the agenda for today's session. First of all, I'll give a brief introduction to Farragut and talk a little bit about our experience in business intelligence and analytics, as well as with the AWS platform. Next, we'll consider some of the key benefits of the cloud, which will help us set the stage for what the AWS platform looks like and how its individual offerings can benefit organizations. And we'll then take a deep dive into a few of these tools, featuring some live demos, followed by a final wrap-up of the presentation. For those of you who don't know Farragut, we're an independent, global professional services firm specializing in business intelligence and analytics. We're a global company with offices in New York, Philadelphia, London, Bangalore in India, Singapore, and Sao Paulo in Brazil. All of our consultants possess a unique mix of skills, blending business understanding with a strong technical aptitude and a deep understanding of analytical tools and techniques. And we offer a full range of BI and analytics services, including strategy and roadmaps, requirements, design and implementation, as well as training and support. Our clients typically span 4 data-rich verticals: consumer goods, pharmaceutical and health services, banking, and insurance. Our clients are some of the leading organizations in these sectors, and we take a lot of pride in the long-standing relationships we've fostered with names you see here. In terms of the technologies we work with, we're an independent consulting firm, meaning we don't work with one specific technology. We do, however, work and partner with many of the key players in the market, obviously including Amazon Web Services, in order to provide our clients with the solutions that best suit their needs. So let's start by getting a grounding in why cloud can be beneficial to organizations, which will help to later highlight how we get value from the AWS platform. Leveraging cloud for your business, when applied in the right way, can provide many benefits. First of all, it can provide cheaper storage methods than traditional on-premise solutions and ongoing reductions in cost for the maintenance of technology and equipment. The time to value when delivering applications can be improved, as outputs can be proven and delivered faster. The dependency on your organization's IT and existing internal infrastructure can be reduced, aiding business users in their ability to make decisions independently. The scalability and therefore elasticity in volume and size of the business can be improved to fit rapidly evolving business needs. Most cloud services are billed on a subscription basis or as a pay-as-you-go model, so you only pay for what you use. This also avoids upfront capital investment, so a key benefit to a number of our customers. With cloud vendors responsible for system monitoring and maintenance, IT personnel are freed up from infrastructure duties, so they'll have more time to develop solutions. The use of cloud can enhance your adaptability in terms of the ability to integrate new functionalities and data sources, enabling agile adjustments to business developments. Experimenting with cloud technology is inexpensive and easy to implement without changing existing infrastructure. Mobile publishing and viewing capabilities are built in for many cloud technologies, making mobile reporting easily accessible for all business and IT users. And finally, the cloud can expand and expedite your distribution of business intelligence and analytics outputs by reaching either wide or specified audiences instantly. Now that we've explored the benefits of adopting the cloud, let's take a look at the offerings specifically available to us through the Amazon Web Services platform and think about how they can drive value in our business. This is the diagram that Amazon uses to organize its product offerings. I personally find it very helpful in understanding and orienting within the platform. The offerings are grouped into categories of services, but note that a single offering may be found across a number of different groups. This is not meant to be a definitive guide to everything the platform can do, but merely a visual to enable us to get a better grasp of the platform's capabilities. And today we'll look specifically at a few groups that we find to be commonly used within the field of business intelligence and analytics. The first group is obviously analytics. Popular technologies within this group are things such as Amazon Redshift and AWS Glue. These products really enable us to dive into and transform our data. With data exploration, we can gain a better understanding of what data we have available and what types of business questions we can use it to answer. And we are able to transform, move, and report on our data to enrich the raw data and arrive at valuable insights. The second grouping is compute. So this group includes things like AWS Lambda and EC2. Perhaps you've been perfecting some data transformation or analytical functions that are frequently used across your organization and you want to share them widely. Or maybe you've been experimenting with building out a business application on your local machine, and now that you've proven value, you need a platform to host and run that application. Or maybe you're simply interested in running a product that your organization uses daily, but you want the infrastructure sitting underneath that product to be able to ramp up quickly when necessary. Essentially, if you're in need of the power to run something, you'll want to take a look at the variety of offerings under compute, from the efficiency of serverless code hosting in Lambda to the customizability of full-scale machines in the cloud through EC2. Now let's look at the database group. So this includes RDS, DynamoDB, and Redshift. In the same way that we commonly structure, attribute, and organize our data in on-premise databases, AWS allows us to do the same across a host of different types of data. This brings the added benefit that if we don't want to, we don't need to worry about common database management tasks like server and hardware management, database setup, backups, and so on. These can all be handled by AWS. We can even allow AWS to help us with scaling the databases so that as our data grows, or perhaps as our user base grows, our database can grow as well. Next is machine learning. So this group includes things like Amazon SageMaker, Comprehend, and Translate. This group essentially contains two major types of offerings. One are tools like SageMaker that allow us to create and work with machine learning models. And the other are services that allow us to use sophisticated machine learning already built by Amazon to enhance our business applications. So examples of these services are things like text comprehension, text-to-speech and vice versa, image recognition, and so on. The next group is migration and transfer. So this includes AWS database and server migration services and data sync. A number of our customers are in the position where they've already invested a vast amount of time in the setup and build out of their on-prem architectures. And so they could be forgiven for thinking, these services sound very useful, but I don't want to go through that again. This is exactly where tools within this migration and transfer group come into play. It can be as easy as just clicking a few times to migrate some specific data, migrate a table, a database, or even an entire application into AWS, as Scott will demonstrate later. So what does this mean for your organization? It means that the barrier to entry is quite low, and you can get started with exploration of and experimentation in AWS quite easily. The final group I wanted to call out is storage. AWS offers a variety of storage solutions. One of the simplest yet most powerful offerings that we see commonly used in AWS is S3, or Amazon Simple Storage Service. Maybe you have a subset of data that you just need to land somewhere while you do some experimentation across various AWS offerings. Or maybe the nature of the data you're bringing in, such as streaming data, makes the flexibility and scalability of cloud storage quite appealing. Perhaps you have some colder data that you don't need very often, so you want to save money on the cost of storing it. Or perhaps you've been working on a full data lake strategy across your organization and are interested to use S3 to support your architecture. Or you may already have some business-critical applications that you're running in AWS, and you need the ability to seamlessly set up regular backups. Offerings such as S3, EFS, AWS Backup, and many more are all available through this storage group and can help you keep and organize your data in a way that makes sense for both your users and your budgets. That was a whistle-stop tour of the AWS product offerings, but I hope it helped to set the scene. With that, I will now hand over to Scott to take a deeper dive into a few of those technologies.
Thanks, Evelyn. For this first use case, setting the stage as working for a consumer goods company, and let's say that we're particularly interested in tracking sales. And we also have a sales database that our business uses pretty commonly. For this demo, we're just using, for those of you familiar with SQL Server, we're just using the sample AdventureWorks database. And we've been running this database on-premise within our organization, but recently we've started to face some challenges. So with the rise of a number of business intelligence initiatives within our organization, there have been kind of a number of different efforts recently to further attribute the data, maybe keep some more data within our systems than we've been keeping previously, and even going down to new levels of granularity, as more and more users come in and they want more data for their specific cases. And then we also have significantly more users, quantity-wise, as well as applications trying to connect to our source systems and potentially even more onerous queries that they're trying to run against our systems. So what this essentially means is that there's a lot more strain on these source systems, and this rapid growth has been pretty difficult to predict and even more difficult to keep up with. So this is particularly problematic because, like I said, this has all been on-premise. So we have a lot less flexibility in the underlying infrastructure and have been less able to respond to some of these new needs from the business. So instead, we're now looking to migrate some of our sales data to AWS. So to do that, we can first take a quick look at what we have running on-prem. So when I'm connected to this database, as I mentioned, we're using the AdventureWorks database, so we can see a lot of the sales information that we have in here. So we have information about products, we have information about sales, we have information about the people to whom we're selling, a little bit more information about our organization, all saved within this database. So that's all available here. What we're looking to move to from this on-prem SQL Server instance is AWS RDS, which is the relational database service in Amazon Web Services. So as Evelyn mentioned just a couple of minutes ago, this is a distributed relational database service in the cloud. And to make that migration, we're using DMS, or AWS Database Migration Service. So I can pull that up on my screen here, and we can see this task that we've created in DMS, which is pulling from that source, so our on-premise source of that sales database, and migrating it to an instance of SQL Server in DMS. So as far as the migration itself, that database is probably a couple million rows all in when we take into account all the tables. And really from start to finish, the migration itself was about 1 to 2 minutes. So not much to speak of in terms of overhead of really making the movement. But some other interesting things that we can look at is that on this same kind of migration task, we can add a couple of additional levels of complexity if we so choose. So if we look down in the mapping rules section of this migration task, we can see a couple of things that, maybe as we migrate to the cloud, there are some things we didn't love about the on-premise database that we want to update. So those ones that we've called out here are pretty straightforward, but there's a lot of flexibility in what we could potentially do. For example, we have some sales information maybe we want to filter, so maybe we have some pretty small records. I think in this case we filtered out any sales less than $1,000. Maybe we're not really interested in looking at those for some of our analyses. So doing a bit around that. We also didn't want to migrate some of the logging tables. Maybe we want to start over as far as logging within our new database. And then also, maybe some of our users didn't love that one of the schemas in our database is called production, and we want to rename that as prod. So if we go into this specific mapping rules JSON file, we can see some of these details. This is where we're renaming the production schema as product, since it mostly has product information within there. We can also see that filtering that I mentioned on the sales data. So we're filtering out any sales that are not greater than or equal to $1,000, and also filtering out the DBO schema. So a little bit of transformations that we're doing here, but quite a bit more is possible. As the migration itself is going on, we can watch all of this within the CloudWatch Management Console, so we can see kind of the upgrade or the migration as it happens. Again, I think this was about 2 minutes or so start to finish. Then finally, we can navigate over to Amazon RDS, which is that kind of target relational database in the cloud that we're moving to, where we can do monitoring if we so choose. You can also get information about that same database. And then from an end user perspective, really go back into Management Studio where we were working before and reconnect back to that database that's now running in the cloud. So if you think about from an end user perspective, really minimal interruption and really not too much difference as far as experience. It will feel pretty similar to them with the exception of a couple of those changes that we made along the way. So like I mentioned, there are a few logging tables within the DBO schema that we didn't want to include in this updated database. We also renamed the production schema to product, and we did a bit of filtering on the sales data. So I have a query here that looks for any sales records less than $1,000, and we can see that none of those migrated to our cloud database. So as far as why this is helpful, there are kind of a couple of reasons. So one of the concerns we've seen with customers that are interested to move to the cloud is that a number of systems may need to be migrated all at once. And this means potentially a very large upfront investment before we start to see some of that value delivered. Well, another interesting feature from DMS, from the migration service, is the ability to, if we go back over to the task here, not only have that one-time migration, but also do some ongoing replication. So in this case, we can change a couple of records within the source database, and it will migrate those changes on an ongoing basis over to the target database. So this kind of incremental update functionality allows us to split up where these migrations happen. Maybe we can keep these two databases running in parallel during the transition. That way, some of the upstream systems that are used to pushing into that on-premise database can continue to run for the next few months as they're updated, shifted onto AWS, whereas some of the downstream applications can start that cutover to the new sales database in AWS without waiting for everything upstream to be ready. And this kind of allows our organizational migration to the cloud to happen in parallel rather than in sequence. So if I jump back over to the slides here, we can also kind of relate this back to some of these benefits of cloud that Evelyn had talked about and sort of think about which of those benefits we're able to draw on here. So kind of the obvious one is time to value. What can be a pretty onerous task to do manually, trying to rebuild an entire database by hand can be pretty time intensive. It's clearly quite simple, it's quite smooth through AWS and through its offerings of DMS and RDS. So that's kind of a primary benefit, but it also enables us to get value from cost, meaning like some of the cost savings of having that database running in the cloud, the scalability benefits of, as more sales data comes in, we can grow the power behind the database accordingly, benefiting from the subscription model, and as Evelyn mentioned before, kind of doing away with some of those previous database and server management tasks that we had needed to do. So then if we want to continue with our consumer goods example, now let's say we have another data source within our organization. Maybe it's some shipments data, maybe it's some transactional data from another system, could even be third-party sales data that we're already ingesting internally. But regardless, we have a sample file called salesdata.csv. This sales file just essentially captures some information about what products we're selling, what customers we're selling them to, when we're selling, how much we sold it for, that sort of thing. So we have those types of columns involved. We could build out a quite involved full ETL process for this data ingestion, get this into the same system that's feeding our sales database, or we could simply tell this specific file exactly what we want to do with it. So again, I'll jump back over to AWS to show some of the things that we can do with this file. So first I want to look at S3, which as Evelyn mentioned is a storage service. And we have a couple of different folders within our S3 bucket here. We have a staging folder where we're going to dump the files initially, and then we have some accepted and rejected folders as far as we're going to do some checks on this data and whether or not it's matching our expectations, running some actions accordingly. So first I'll click upload here, and I'll also drag in this same sales data onto my screen. And you can see that it's now available within the staging bucket, or within the staging folder of this S3 bucket. And again, I can jump over to CloudWatch, where I'm looking at the logs for sort of this process that I've set up. You can see a task that I've just kicked off, which is looking at this salesdata.csv. It checking it for the right columns. It's making sure it has the right number of columns, that they're in the right order, and it's done a quick scan of the data, and it acknowledges this is the data that we're looking for. It's going to move that over to the accepted bucket. So as far as how we're actually doing this, we're using Lambda, which is kind of serverless function hosting. So again, we can see if I look over in the Lambda view, this S3 bucket is the trigger for this Lambda action. So we can see anything that's created within this staging folder triggers this action. And then if we look at the function itself, it's as simple as writing a few lines of code to tell that file exactly what you want to do with it. So in this case, we are checking to make sure that it has the right columns, make sure it has the right number of columns, they're in the right order, that sort of thing. And as long as the file looks okay, we're moving to the accepted bucket. Otherwise, we're going to move to the reject bucket for a couple different reasons. But what's so nice about this is how flexible it is. So it's super easy to maybe add in one more column that we want to bring in. Maybe we want to add a calculation while we're doing this. It's all as simple as writing maybe one more line of code to do whatever transformation we're interested in doing. We can also see if we wanted to upload something that's definitively not the sales data that we were looking for, so maybe this kind of test file that doesn't have all of the right columns, I think it's missing some of the information about products, then again, I can go back over to CloudWatch and I can kind of watch this transformation in progress, and I can see, it was missing a couple columns. Some of the columns weren't formatted correctly. All right, it's going to move that over to the reject bucket. So then if I go back over here, look and reject it, I can see my file, the test.csv from today. So again, these transformations that we showed just now are pretty simple, but your imaginations can kind of run wild with what is possible here. So maybe you have systems feeding directly into the staging bucket. Maybe you have some more complex algorithms that you're running on top of your data as it comes in, or maybe you're triggering additional actions in Lambda or in other technologies using Lambda after that initial ingestion is created. So again, to recap some of the valuable aspects of this transformation, obviously two of the primary ones are cost and scalability. So like I said, we don't have this massive ETL structure that's bringing in a ton of different systems. It's pretty clunky. It's really just one function or one set of functions running in Lambda that runs only when we want it to, only when we ask it to, and only using the infrastructure that we've given it the freedom to use. So it can kind of scale up as much as we want or as much as we allow it to. So that scalability is kind of another key benefit. As you can see, it's also pretty easy to kind of grow and change and develop this process as maybe more columns come in, what transformations we want to make change a bit. So again, it's pretty adaptable. And then one final quick use case that I would want to run through is some enrichment. We've migrated our data to the cloud. We have another source system that we've kind of ingested and transformed alongside that data. And then this kind of final use case is maybe we want to look at some data that we haven't seen before and bring that in for some analysis. So some folks from our marketing team within our organization have actually recommended maybe looking externally at some social media data to kind of get a better understanding of our sales. And this isn't something we've done much tracking of before, but our potential vision at least is to gain an understanding of customer sentiment around our products and then start to relate that back to sales performance. So for one last time, I'll jump back over to AWS here, and we can talk a bit about how this is set up. So we have this Kinesis stream. So Kinesis is a technology for doing just that, for streaming data. And in this case, we're actually pulling data from Twitter. And there's functionality for filtering by hashtag, that you can filter by search keywords, that sort of thing. But we have this Kinesis feed that's connecting to Twitter. We can decide, how much data we want to allow in at a time. We can do a little bit of monitoring here, and then either we might want to do some analysis on it in real time, or after we get a sufficient amount of data that it kind of means something to us, then we can push that, maybe somewhere else, maybe to S3 for some analysis. So for that, we've also set up a delivery stream in Firehose, which is an aspect of Amazon Kinesis. So we can see some of the configurations here that after we get 1 megabyte of Twitter data, or after we've been getting Twitter data for 60 seconds, then we're going to kind of package that all up and send that over to Kinesis. So actually, as we've been talking here, I kicked off this process to pull in some of this Twitter data. So I'm going to go to today's July 16th. So I'm going to go here, and I can see these 1 megabyte packages of Twitter data that are coming in. And again, we could focus these down on our specific products and kind of pair that alongside our sales data to kind of get a better understanding of how does customer sentiment relate to current and potentially even future performance. Kind of wrap up, jumping back to the slides here. If we think about some of the benefits of this process, one major one is reduced dependency. So previously, an effort to bring in an entirely new set of data like this, especially streaming data, would rely quite heavily on our internal architecture. It would also mean quite a bit of investment in estimating what the data loads would be, what type of infrastructure we need before getting a chance to really play around with it. And for something as difficult to predict as social media, this would be a pretty challenging exercise. But AWS kind of abstracts us from this. So it allows for experimentation and enables faster and kind of more in-depth playing around with this data. You know, we can quickly rule out ideas that don't prove a lot of business value, so maybe we can't find a good connection between sentiment and sales, and we've experimented for a little bit, but we don't invest too much in it. Or maybe we find some interesting insights and think, you know, this is a fast-moving, high-value initiative, and this is where we want to direct some of our effort and some of our investment. So thank you all very much for joining us today. And again, please don't hesitate to reach out to Evelyn or to myself with any questions that you may have. Thank you very much, and have a nice day.